Hello everyone and welcome to the first Angular Belgrade Meetup. Today we have one very interesting talk about NgRx Component Store by Okrushko. But before Alex starts his talk, I'll first introduce you our Angular Belgrade group. So I founded this group with few goals in mind. First goal is to build Angular community in Belgrade and Serbia in general. Second goal is to have a place where we can share our knowledge about Angular, RxJS, TypeScript, and all other Angular-related stuff. And third goal is to help beginners learn Angular. If you want, you can follow us on Twitter and LinkedIn. You can also check out our GitHub profile where all the sources from our meetups and workshops will be available. And you can contact us at angularbelgrade@gmail.com. If you want to speak at the Angular Belgrade Meetup, you can submit your talk at the following link. And don't be shy, if you have something cool to share with us, feel free to submit your talk. And okay, that's all for me. Let's go back to the main topic for today. So NgRx Component Store is the latest library from NgRx family, and it's used for local state management. Alex is one of its co-creators, and he's also software engineer at Google, Angular Toronto organizer, core member of NgRx team, and NgRx maintainer at Google. Hi, Alex, and thank you very much for joining us today.
Hey, all. Thanks for having me. There'll be some surprises, I guess, during my presentation as well. So that's all good. All right, let me just do this a little bit here. Good.
Yeah, you can start now. The stage is yours.
Thank you. All right. So I'm going to be talking about a component store, which is the latest library in Angular, in Angular and NgRx that I think would unleash the whole new patterns and new. It basically empowers you to do state a little bit differently, right? So up until a certain point, up until now, we had global state management libraries like NgRx, and that's what NgRx is known for, right? The NgRx Store, which is actually used in one of every 6 Angular applications worldwide. It's by far the most popular. And then there are also different approaches like behavior subject or no state at all, right? There's basically sometimes state is just like it happens to be at a certain place, so it's there, and it's not a lot of thought given to it. So I'm going to talk about some of the state issues and how we can solve them today. So by the way, if you have any questions, feel free to throw them in the chat. I'll be monitoring as well. I'll be very happy and excited to actually answer them. I use this opportunity of having this live discussion, and again, I'll be watching them. So feel free to drop questions here. Awesome. All right. So I got already introduced. There's a little bit of change. So I'm switching to from Google and Firebase. I'm switching to Cisco now. So I'll be there as a principal UI architect at Cisco for the customer experience products. I still am the NgRx team member, so that doesn't change. I'll be participating, still keep participating very actively there. And Angular Toronto is what I organize. So I'll be happy to have you watch it or have you, present there as well if you have an interesting topic. So please reach out to me. And other thing is I really like this in-depth resource. So do check it out as well if you have time. This is where a lot of great knowledge was shared over years. So and it still continues to be. So check it out. All right. So this is the fun part. If anybody knows who this guy is, anybody knows? Yes, Albert Einstein. So he had this famous quote, right? And his quote saying, synchronizing state within the application and the backends is one of the most complex tasks that developers have to solve. And you're like, he never said that. Well, you're right. You're right. He was before the internet, so he never had the problem of this state. He had different problems with state, but if he was with us today, I'm sure this is the one he would have said. Synchronizing state is really a problem. And we as developers, solve this problem whether we want it or not, whether we're explicitly facing this thing and having those state flow diagrams or not, right? In any case, we do have state in the apps and we have to deal with it. But what is the state? Some of you like, and what is it we're trying to manage? Because those state management libraries, they're managing the state, right? So to understand what we need to manage, right, let's first understand what the state is. So what is the state? And again, there's multiple ways to split it up. I really like something that that I first saw from Victor Sufkin. So the way what I saw is there are basically two types of state, right? There's two kinds of, right? This is in server, there's one state, and there's a web app, there's another one. So for now, let's assume server just has some kind of backend state. What we're more interested is the web app state. And we have a few kinds. And the ones we'll take a look at today is persistent state, URL state, client state, and local UI state. So this is the ones that we'll be taking a particular look in today. And this is very important, I think, to understand what those are, because managing the flows of them is what the main problem is. So what is the persistent state? Persistent state is the state or a snapshot of a state that we get from the backend or we persist back. This is our JSON that we get back, right? Those are all our requests and responses that go there. This is all our AJAX, right? So this is a persistent state. We're persisting it to the backend. It's being saved at the backend. And we're actually getting the snapshots back as well. So this is a persistent state. Then we have one very important other state, a URL state. And this is the state that drives so much in our application. It's so critical to get it right. This is the state of our URL and the router. So sometimes that means the router as well, or the data that it has. So that's the other one. Second one is the client state. Client state, the way I like to think of it, is something that is important in the scope of the application, but it's not persistent to the backend. So it's state that is application aware, right? For example, in this case, which tab is open. So application is very well aware of which tab is open, but it's not persistent to the backend, right? We're not saving to the backend which tab the user has open. So that's the client state. And then there's local UI state. And local UI state is the state of this, for example, slider button, right? Inside, it takes some kind of input probably, but inside it's completely encapsulated. It just reflects it in the UI, right? For example, is it enabled or not? The button can show you. But button is no awareness what it doesn't mean to be on and off. All it does is just like, oh, I'm on. Somebody clicked on me. Okay, and now I'm off, right? And it just communicates that to the parent components. So those are very frequently like presentational UI would be your local state. Could be more in those lines. So managing these states is actually pretty hard, and especially if your application is very functional, where there's a lot of things happening. This is where the most problems come in. Error handling as well, and some of the race conditions. Like those are the things that, and those all of those state flows, how they're going back, how they shared through other components. All of these interactions are one of the most complex tasks that we as developers have to solve. All right, so that's that. And we have some help of how to solve it. We have Angular. Angular is really good. Angular is an opinionated framework that provides, a lot of batteries included for us, which is, it provides us the forms, it provides us the components, it tells us how to do the pipes, it even provides us the services, right? It has its own HTTP client. So a lot of things are like, it's opinionated. We do things with a certain way. We have ng modules and things like that. But is it though? Is it opinionated enough? And this is where I think we have this great opportunity, or we have this with NgRx, because NgRx saw this opportunity where Angular was not opinionated enough. For example, yes, we do have services. We do have services, but anything with the state management, I think Angular still wasn't there. It wasn't providing those things. So it had no quite an opinion on one of the most important tasks that we need to solve, is those state flows. So I think we kind of solved it with NgRx, and we'll see today why. And we'll use it as an example. There's a very simple application that has basically 3 pages, right? The first page is, that's just a list of products that we have. Then we have, once you click on the product, you have a product details page. So it has more information about it. This is where you can add things to the cart, for example. It has description and things like that. Notice the cart there on the top right. And finally, once we clicked on that cart, it shows us what we have in our cart. For example, we have here 3 different types of products, but 4 products in total. We have 2 of, for example, sheet music. So quantity also is included here, right? So every time we add item to the cart, we get it here. Awesome. So we have that. Let's start from one of the most basic components that we can have here. Let's start from the cart icon. This component needs to know what to show, right? It basically needs to show what's the count of in the cart, right? And this component can be completely presentational, and then that way, it just gets it through the input, and it has the cart items there as its local state. So it just, but then we have to have container component that provides the data to this presentational cart icon. The other approach we could take is, well, we can make this already more aware of the client state. And for example, it would get, or actually in this case, it would be persistent state. In this case, it will inject some kind of service into this component. And in this case, it would be cart service. And the cart service has this get cart product, right, call. And you can see by having it a pipe, right, this gives us some information that's observable already. And we transform those cart products, which could be an array of things, right, with the map function, map operator, we transform it to a single number, right? So we'll have observable of numbers. So we change it. It's now a reactive thing. So it's now an observable. Great. So we have that. How does the cart service look like? Well, in this case, cart service is something we call a pool-based service. It has no state. It's completely stateless, but it has a bunch of methods. In this case, this method is the get cart products, which returns us an observable of those cart items, right? And then you remember we pipe it through a reducer function there to get to actual number. But what's interesting here, the get cart products returns you this observable back, right? So every time you want to get the new data, you call this method, the get cart products, and it'll just give you that information. So in a way, we need to pool the information from the cart service. This is a pool-based service, and it's, again, completely stateless. Remember that state, because we'll use it soon as well later on. Great. However, the data here is a little bit more interesting than just getting it once from a service. Let's take a look how our app is structured, like component-wise. So we have this cart icon component, right, that we saw. It itself is part of the header, right? Then we have a bunch of cart product components that we have there. And again, it's very oversimplified even for this application. So we have a bunch of cart products. All right. And then these cart products are part of cart page. We'll skip the buttons and stuff. At the end of it, we have a router outlet that handles it. So header stays the same, while router outlet changes from page to page. This is the structure that we have. And finally, the whole thing is in the app. So this is how our app is structured, right? Let's take a look at it and have it as a component, two-component view. All right, so this cart icon information is needed, or cart items, how many cart items we have, or what cart items we have, is needed in two places. We need it in the cart icon component, right? And we also need it in the cart page component. So this way, we need it in two places. How can we share that data across? Well, one of the ways we can do it is we can have a cart service that provides the data to the app, where basically you find a common node, the first common node between these two, and then just, through the inputs, just propagate it down. You would rightfully agree right away that, hey, this is wrong. That doesn't feel right. Now our cart item is just spread throughout the entire application. And now every component needs to pass it on, even when it doesn't use it. Like header in this case doesn't care what are we passing. And then now, refactoring or changing anything becomes a problem. Testing becomes a problem. A whole bunch of problems. So this approach is bad on many levels, and we definitely don't want to do this. So how can we do this now? Well, we can have a service that's basically injected into two places, right? And we have the get cart products, we call one, and we have the get cart products, cart items, in the cart page. But now I have a different problem. We need the same data, but each component would ask it independently, which would result in a few network requests for the exact same data, maybe even at the same exact time. So how can we solve this? How can we make sure that we're not duplicating network requests? And again, there are multiple solutions. Let's take a look at one of them. One of them is to expose this cart items as an observable. So it's still an observable, but now it is a property in a cart service. And when we do this, well, we initialize it with this data. So we'll get the cart products, and then we'll share replay. So what the share replay does, it will share this information between those two components, right? So they can just listen for the cart items themselves, and it won't make those repeated requests. So we'll just do the request once. So our cart service now becomes stateful. We have a state. So read-only cart items here is a state in the service. It's no longer stateless. We have a state. How we consume it? Well, instead of calling the get cart products now, we can just, listen for this observable. And once it emits something, we'll push it through this map and we'll get our count. So this is one of the approaches, and it works in some cases. However, it doesn't work in some other cases. In our case, it won't work. And why doesn't it work in our case? Well, it appears that our cart products data is not static. It's dynamic, and we can change it within the application. Let's take a look. So first of all, you can remove items from the cart. You can purchase cart items. You can remove everything, right? So that affects the number of products that we have in the cart. Moreover, we can add more items, right? So that data is very dynamic. There's multiple things that can affect it on different pages. We definitely don't want, and how can we solve this? We definitely don't want our cart icon to be concerned of what's changing the data, right? We want cart icon just to reflect the changes. We don't want cart icon to know what's changing the data. Is it the add to cart button click? Is it remove click? We don't want cart icon to know who's doing it. We just want to let it know that it's something did it. So we already moved from push-based to pull-based, from pull-based to push-based. So we are no longer asking it, but we now are listening for this property. How can we make sure that this property now reacts to those changes? So the way we can do it is something's known as service with a subject approach, or reactive service, or service with a behavior subject, or observable service. There's many, many names for it, but in a nutshell, it's the same thing. In a nutshell, we have a keeper of a state in the service. For example, in this case, it's the cart items subject. It's a behavior subject, so it needs an initial data. For example, in this case, would be just empty cart item array. So now that data could be changing over time. And the way we expose it, we still, and notice the subject itself is private, but the way we expose it is through those read-only property of cart items, right? So we do that subject dot as observable, and that exposes it as an observable. So now you can start listening for things in it, but you can't push it anyway. So we have the state is still encapsulated in the cart service. And it's very important that it stays encapsulated, right? So consumers can read. If consumers want to change anything, they'll have to call methods on it. And in this case, we have the add product method, for example. They'll take the new ID, right? And they will do this post request. So similar to what we was doing before. However, in this case, it no longer returns you an observable. It returns you void, right? This method returns you void, nothing. You can't, it doesn't return anything in another word. So it does a post, it subscribes right away, and it pushes this value that we get, the new array of those items, into the subject. And then what happens? The subject reacts to it, right? So it's an observable, cart items get updated, the new value is pushed through the system. So how can we consume this thing? Well, we're still listening for the cart items, and now it's a really truly reactive property, right? The read-only cart items is a reactive property. Whatever is changing it, our cart icon component doesn't care what's changing it. All it cares that it is changing. And this way, our cart icon component can react to it and compute the new value of how many items there is in the cart and push it into the template. What else we're doing here is in our constructor, we're calling the cart service get cart products. And what that would do is we'll notify the service that we're interested in that data, right? So get cart products is invoked, subscribe, the data is pushed, it's all reactive, great. But it does suffer, again, a few more problems. First of all, we're getting back to where we do duplicate network requests. So for example, the general page for a cart content page or cart detail page would also need to let the service know that it's interested in that data. So we'll also call the get cart products. So it would be called again. And the other problem that we have is, say for example, we're adding item to the cart. So we're adding the adding product. And we have a very happy user who was really excited to add many items. Every time we click the add product, it will cause the new HTTP request, right? So because that's the way it's set up right now, right? To remember that method, it will trigger the method, will do the post. But it could happen that the second click, the response from the second click arrived before the response from the first click. This is network requests we're talking here. So there's no guarantees of how this thing's happening and how the backend would process us again. No guarantees. So we could end up with something that's called a race condition. A race condition, in this case, between clicking add products. So how can we handle this one? Well, right now, the way we are sending those requests, we cannot control with the current structure. However, NgRx for years now has been providing a structure that can really control the flow of data and the order of those network requests, which are called effects. Being the global NgRx store or the component store that we'll take a look in a second, they both have this effect, and they are for controlling race conditions. They're also one of those places where you put all your asynchronous stuff in and all that stuff, but one of the things that it does is controlling the race conditions. So let's take a look at the component store. Component store is a state management library. However, the state management library is actually just a single file. It's a single file of 350 lines of code that has a few other helpful operators. But in a nutshell, it's still just a single file. And being a state management library, it needs to do two things. And by the way, NgRx Component Store is completely independent from the rest of the NgRx. It's self-contained library. So it doesn't have any of those dependencies. So being a state management library, it needs to do three things. It needs to be able to read the data. It needs to be able to write the data, right, that it manages. And one other thing is control those side effects that we have. So we can read the data with the select function. We can write with updater. We can also patch now, thanks to Marco. He added the patch updater as well, patch state. But anyhow, these are the main ones. And then we can also have the side effects with the effects, so we can control those. All right, let's take a look at one example how we can do this. Let's rework our cart service. So first of all, we'll declare interface, and this is the state that this component store would be working with. And in this case, it would be cart state. It would still keep track of our cart items, which would be an array in this case. Then we make the service injectable, right? And in this case, we provide in root, but this is not my favorite thing. But for this case, we'll provide it in root. We extend component store to get access to those methods. And we'll provide this interface there, so as a generic, so it is aware of what state we're working with. Then in the constructor, we'll inject any dependencies that we need. In this case, we're injecting the cart state, cart service. But this cart service that we're injecting here is the initial version of it. Remember that pool-based, completely stateless one? It's just a simple wrapper around the HTTP calls. This is what we're injecting in here. And then we need to initialize our component store. In this case, we'll initialize it right away in the constructor with a super call to provide this initial state. However, we could also do lazy initialization should we need that, okay? Now, so now we created it. How can we read the data from it? Well, we read it with this select that's provided us by component store. And in this select, we'll tell it how exactly we want to extract the data or transform it to from our state container. So in this case, we'll say, okay, our entire state, and we just need to care about the cart items, so we need to extract them. So we pass that callback. We'll say state, we're extracting the cart items out of it. And what this select provides us an observable now of those cart item array. Now, the next thing we'll need to know from it is the count. And we can do it here right away. We can provide like read-only cart items count, and we'll do select. But in this case, we won't be passing the state. We'll be passing the other observable. And whenever that observable emits, we'll use this function to reduce this items to a single number, right? So this is the same function that we're using. This is just a pure function, right? So in this case, select can also take an observable or multiple, actually, right? And then it can aggregate those values, or single value in this case, and calculate the final value that we want from it. So cart items and cart item count are observables. They're not selectors, nothing like that. You can call them selector, but they are really just an observables of values. And the beauty of select is that it not only selects it, but it also makes sure that it's super performant. It has all those distinct until change, so it doesn't emit the value if the state didn't change. It's very performant because it shares as well, right? So if there are multiple subscribers for the cart item observable, they are sharing the content. So each one's not retriggering every of those things. It's pretty smart, and it's very high performant. It also is a high performant way to accumulate data from multiple observables as well. I'm not going to touch on it today, but you can go into the docs and read about it. It's pretty cool how it does it. All right, so this is how we read the data. Now we need to write, by the way, we need to also, how will we use it in our component? Well, in our component, we can just inject this cart store. So this cart icon component, you can inject the cart store just like we do with any other injectable service. So it's still a service, even though we call it a store. And it can just read this observable property. Notice cart icon component doesn't have to know that the cart store is a store. It can just work with it as any other service, right? So it's just any other service. It has a property, it just subscribes to the property. It doesn't even subscribe, it just assigns this property in the class, and then we'll have a sync pipe in the template to unwrap the observable and start listening for those values, right? Great, so this is how we read it. How would we write it? Well, the way we write it is we have this set cart items, and we have an updater functions for those. What updater does is it takes the state and it takes the value that will be passed to it. And then it basically reduces or transforms it, or basically returns a new state that we need to settle this update. And set cart items, it might look like a property here, but it's actually a callable property. So you can think of it as a method. And whatever the value that will pass to that method will be passed to the second argument in this callback that we have. So in this case, cart items. And you can see there at the bottom where we call this set cart items, and we're passing the cart items. So this updater will then trigger the update, and it will update the state with this new value. It's really powerful as well. And it's very, very type safe, by the way. The entire thing is really, really type safe. Type safety is something that I in particular care about. And NgRx as a whole was one of those libraries who do have very strict typings as well. And then, by the way, we also see this this update status. We don't have this updater here, but I'll show you an example. Again, you just take a value, and it will it could update the state with the value. Okay. So now let's get to the final part. The very exciting part is this side effect. So effect, we handle them with effects. So let's take a look at how this one's structured. So we have this effect method that takes an observable of, in this case, IDs. So this is an observable. And then we'll tell it how to behave when we get multiple of them. So for example, here's stream, right? And we start piping these IDs. And the first thing that we do in this case, we'll concat map. We'll use this ID. And in this case, we'll call the service to add the product. And in this case, remember, our cart service is a completely pool-based. It just returns the observable, it just does the call and all that. However, we can control all these race conditions and everything that we need for it in this flattening operator, concat map in this case. What concat map does, it's one of those flattening operators. We have 4 of them, right? And they can help us handle those race conditions. So what concat map does is, say we get a new value, ID, right? And it starts calling the service with this ID. And say a new one arrives, right? User keeps adding those products. So the new ID arrives, and what concat map does, it says, okay, I'm busy right now with adding this product ID. So it queues the new values until it's done with the inner observable. When it's done with the inner observable, you'll take the next value. Say, what are the other 3 operators? The other 3 operators would be exhaust map, switch map, and merge map. So concat map queues things up. But for example, switch map, which is quite popular, when it gets the new value, it starts, obviously triggers the request. When it gets the second value, what switch map does, it cancels the previous request and starts the new one instead, right? So that operator could cause some bugs during race conditions. So especially if you're trying to add the products, like that probably is not the right operator. Concat map is definitely the safest one. And then we have exhaust map. What exhaust map does is it starts the first one, right? And then the second one arrives and says, I'm already working on something, and it completely drops the second one. So it will keep ignoring values until the inner observable is working. So obviously adding a product is this is not what we want as well. And final one is the merge map. And merge map, contrary to what concat map does, concat map queues them, but merge map starts them in parallel, right? So maybe adding a product is also not a good idea because the result of the call is what we use. And this is the default behavior of the behavior service with the service with the behavior subject that we had before. It was using this merge map strategy by default. And the thing is, we weren't able to control it any other way. This way we can, right? So we have those flattening operators that we can use. So, okay, we call this add product. What do we do next? We have a result back. Remember, that's an array. And the next thing we'll do, we'll tap it. And we'll say, okay, when we have the next value, we'll call this updater, and it will update the state. On the error, we'll call another updater, for example, which will update the state to error or something like that. And one other important part that we do here is the catch error operator, and we'll just push it to void. We already handled the error in the tap. The only thing we need to have this catch error and push it to the transform into the empty observable is so that our observable stream does not collapse. But this, was a very frequent combination that we kept using, this tap and catch error, tap and catch error. They were like basically a blueprint a pattern that we're using more and more and more and more and more. So we decided to create a little operator called tap response that basically does those two things. It's just a little bit shorter, as you can see. And what we do, it would do something on next, it would do something on error. And the difference here, I'm asking you specifically to do something on error because not handling the errors is one of the most frequent causes of mistakes that I've seen. So it wants you to do something on next, it wants something to do on error, and internally we'll catch the error if this is the case. So tap response, available from version 10.1 of the NgRx Component Store, which is available already. All right, great. So the tap response. So how can we use this effect? How would we actually use this? Well, similar to updater, you can treat this add product as a callable property or as a method, right? So we have a product details component that injects the cart store, and it has this add to cart callback probably from the template. And see, it takes the product ID and it would call this cart store.add product and push that ID to it. So from the consumer perspective, from the component itself, using this component store, it almost looks just like any other service, right? It's a method that you call. But notice what's something interesting. We're passing a single product ID to it, right? And we'll take a look at the top. Add product works with the observable stream. So what happens is quite exciting. Every time we call this method, internally, it will push this value into this observable ID stream. And then we already defined how we handle that observable stream in our component store. So that's what we want to do is a concat map, and then we set it into our state. It's really exciting, I think, because it kind of brings back that calling service methods without any extra things necessary around this. There's obviously some benefits and drawbacks of this, but there are definitely benefits compared to service with behavior subject. All right, so now what do we do now? Well, with this cart service, instead of getting multiple things, we'll just have a cart store. In this case, it's provided en route. And then we'll inject them in both a cart icon and cart page for different reasons, right? But this, and now then each one can listen to the values, and also cart page can operate on things, right? Adding things to the store and all that, calling those effects. And one more time, cart page is just, for example, it just calls the methods on the cart store. It doesn't know it's an effect, is it an updater? It's not the concern of the cart page. All right, so this is what we had on the left, right? This was a service with the behavior subject, with all of its drawbacks. On the right, we have a component store, right? This is what we are trying to achieve. And obviously, you'll add also like remove product, remove all, and other things to it as well through those effects. So this is how we do. So this is how the APIs are and the basic idea, what it does. Now, where can we use the component store? Where can we use, those are the use cases. So we already saw this provided in root. There's other use case of complex independent component state, and I'll get to each one in details. Reactive local UI state, and finally a shared common component state. So let's talk a bit about this provided in root case. As you saw right now, we had the component store that was provided in root, the card service. This is not my favorite approach for sure. This leads to having multiple services that are provided in root, always available, always keeping track of state that nobody sometimes cares about, right? So they're just there and all that. We can do better. And also now the state starts to spread a little bit more. There could be a lot of those common components, component stores. And that's the idea, to have them, a lot of them. But if they're all in root scope, now they're just, flooding the thing, and then you'll have components injecting multiple of those component stores. That becomes a little bit more problematic, and this is what we wanted to get away from when we were creating the NgRx Store, for example, right? So there's a single service kind of thing. So provided in root still has good use cases. For example, if state is completely self-contained, and it's very narrow, and it's shared globally. It's used in every part of the application. For example, the permission service, right? Your permissions, user permissions. It's a very thin state, right? So it doesn't have a lot of things that get tracked. It's basically a permission list or array of permissions. But then it could be used in many parts of the application, right? So it's very thin. It's used all over. It's very targeted. So that one's okay to be in root. Otherwise, if you have too many things that are shared through whole application, consider taking a look at the NgRx Store instead. All right, so what are the other good use case of the component store? Well, this is something we call complex independent component state. And let me show you what I mean here. So instead of having your card store in the root scope, it could be attached, basically provided by a specific node that owns the state for all of its children. In this case, component A could have card store in its providers. And this is in the provider's metadata of the component. This is what I mean. So we can have providers for the component. So component has a provider, this card store. That means that each instance of product detail component will create the new store for itself. But what it also means is that card store now is tied to the life cycle of that particular component. That means that when component gets destroyed, all the state is cleaned out as well. So the card store is destroyed, everything's unsubscribed from, it's automatically cleaned out. This is one of the beauties of the component store. Now you can have, say, component A is needed only when one of the pages is opening up. When that page opens up, then we create the component store. We'll do all the requests. We'll do all the updates. It will share that state. Should something be happening there? And then we navigate somewhere else. A is no longer needed. We no longer need the state. It's destroyed, unsubscribed, and cleaned up. That's a beauty of component scope providers. And this is what we call the complex independent component state. The other one is reactive local UI state. And what I mean by that is, say we have a component B, and component B could have, a local state that could be quite complicated, has some business logic and all. My general recommendation, and this is what I try to do for my components, is always have components to have as little of business logic as possible. So in this case, we can basically almost like outsource that logic into the service, which is attached to this component. And in this case, it would be local store, for example, which is a component store. And again, it provides the local store and it injects it to use it right away. So it could be used only within component B. It's very localized to this component. It will be removed once the B is destroyed. It could live side by side with the card store there as well. So they don't interact, or they could interact. But in general, say this is completely encapsulated within the component B, but now you have component B very lightweight. It basically uses those inputs, not inputs, but it uses the local store and calls methods on it. It doesn't have a lot of business logic. It's very easy to work with. And if you had those components that are like 1,000 lines of code and more, you should definitely take a look at this and outsource that logic to this component store. All right, so, and you might also want to break it up into the more components, but that's a whole different topic. So this is like a reactive local UI. And finally, the shared common component state. And this is the use case that actually drove, so within Firebase, when I was Firebase, this is what basically pushed us to create this component store. This was a very common question, actually, internally and externally as well. Quite often, people were asking, hey, I have multiple components on the same page. I have a presentational component, or actually shared or reusable component that has quite a lot of complicated state. It has a lot of children as well. But then I have, say, a few of them, and they interact through the inputs and outputs with the container component that has it. But I have like multiple of them in the same page, maybe like 3 or 4. This could be graphs and stuff like that. But I really like the reactivity and all that. How do I do it all together, right? And before, we only had the NgRx Store. So typically it was like, well, you kind of can index each of those components by some kind of index in a global state, and then you have all this reactivity. But what are you doing is you are pushing something into the global state that has no purpose there. It won't be used by anything else. It's used only within the component itself, only for this reactivity and performance. So now we have a solution for this. Component Store is a solution. Each of those components can provide, when we specify it in the providers, this common store, each instance will get its own store, right? It will get its own component store. So we have it and inject it. And moreover, if we use those instances or inject those component stores in the children down level, they each one get a corresponding correct component store from above. This is how component hierarchy works, right? So if we inject this component store in the second level child, for example, on the left, it'll go up the component injector hierarchy and find a common component on the left that's providing it, and they'll be reusing the same instance. But between those common components, they won't be sharing anything because each one have independent state, and the way they communicate with the container component is through those inputs and outputs. So this is another fantastic use case, and this is the last use case that I wanted to talk about. How does it compare with the NgRx Store? I have like 2 minutes to talk about this one. So sometimes in the global store, the difference is that we have actions. And why do we have actions? Actions is a great indirection. So we already had one indirection with listening to reactive property and calling methods. So we already had indirection. We weren't calling the method directly. So we had this push-based architecture. But now, say a component needs a lot of information and needs to trigger a lot of things. Action provides a second level of indirection. It can do multiple things at the same time. So for example, here, custom ratings that we had. And if we choose to go with the component store, we'll need to get the products and read the ratings. We need to let the store know that we need both of those information. So basically now our components is a little bit more involved, which it needs to trigger. And it could work fine with 2 or 3. It doesn't scale well if you go a lot more. The beauty with action, it can trigger multiple things at the same time. So here, if we just switch it to products opened action that's being dispatched, it can now trigger multiple effects. Each will transform their data, and then a selector, for example, in this case, get product list view model, will just aggregate the data and provide it as a view model to the component. So with the NgRx Store, we are going with a little bit next level, and it pushes the responsibility outside of the component completely. And again, in some cases is the best way. In other cases, component store is the other way. All of those comparison and documentation is at NgRx.io, so you definitely should check it out. All right, I'm not gonna go over the NgRx structure. I think most of you know what it is. So we have store with the reducers and action stream and dispatching all of those actions. I'll skip this for now. How does it compare? Well, we have those read, writes, and effect. NgRx has corresponding create selector, create reducer, create effect. So those both of them do this well. But then there are other, where the differences are is that in NgRx Store, each of those selectors, reducers that update the state and effects are basically all separate files. So it scales really well, right? It doesn't matter because as soon as you grow, you can just create another file and have it there. Well, with the NgRx Component Store, they all live in a single file. So the scope of what Component Store should be responsible for should be really, really small, right? Okay. And then the other thing with NgRx Global Store, it's a single object that has those multiple reducers that each responsible for a corresponding piece of state. So they're still responsible for a piece of state, but it's still a single object. While with the Component Store, there could be multiple of them, right? They're independent, and this is the key. They should be independent state. They should not be duplicating the state in multiple component stores, right? There should be one component store that owns that piece of data. All right, and the other difference is, again, NgRx Store is global, lives through lifetime of the application. Component Store, right, could also live through the lifetime of the application if it's provided in root, but this is not my favorite use case. The real benefits of Component Store as well is that it could be tied to the lifetime of the containing component, to the life cycle of that. All right, summary. Synchronizing state is a very complex task, as you can see. And hopefully I try to prove it, because there's a lot of things that are happening. State management libraries have to help to remove this incidental complexity. What's incidental complexity? This is complexity that just appears to be woven through your application without you even realizing it, right? There's race conditions, there's error handling that's not done at all, most of the cases. All of this is this complexity that just happens to be in your application and you have no awareness of it. So the state management libraries really help you to remove those and be very specific. How do I want to handle those race conditions? I have another value, right? I want you to think about it every time. Oh, okay, I'll use one of those 4 operators. This time would be exhaust map, right? I'm getting getting product detail. If I'm already asking it, I don't need another one, exhaust map, right? So I want to be very specific how those are done. Errors, I want you to handle the errors, no matter what. I want to handle the error. If it's just like writing down to do, handle the error sometime later, you'll have that. And once you actually run into the production bug, you'll come back and you'll have a little bit of, oh, I should have known better. Anyhow, so state management libraries help you remove those incidental complexities. And NgRx to the rescue. We used to have only one global state management, and that's where our team is really popular for. But now we have a second library complementing it, which is really, really powerful. Those 2 libraries could be used independently. You can use one or another or both, right? Because they each have their own problems that they solve really well, right? So now that adds you another tool into your toolbox that you can choose from and target the problems and solutions accordingly. So a bunch of people helped me with this one. Kevin Yelko from Firebase team initially came up with the design. Brendan Roberts and team, the Shriver from NgRx team, who reviewed all the code, provided a ton of great feedback on it as well. So there was a great interaction. But this is my team. Nicholas Jameson also provided a great operator for us, which I haven't touched on. He's from the RxJS core team. And Lars as well spent numerous hours with me, providing great feedback, listening me, and all of this stuff. By the way, Brendan, Tim, Nicholas, and Lars all have blogs. So Tim, especially Tim, Nicholas, and Lars are specifically active. Do check them out. They write fantastic content. So NgRx.io guide, it's at ngrx.io guide/component store. Check out how it compares to the global state store, what the usages are, and all the fun part there, and the APIs. And finally, there are two Discords that I want you to know. There's the Angular Discord, which is an official Angular Discord. There's Angular team members there. There's a lot of Angular GDEs, Google Developer Experts. There's a lot of library authors, a lot of other cool community members. It's international. There's some meetup spaces for Belgrade as well. So do check it out. It's pretty cool. I think it's like over 4,500 people there within the last few months that we had it open. And finally, we also have a Discord for NgRx. While we have NgRx channel in the Angular Discord, this one's dedicated for NgRx, so it's split up a little bit deeper, basically per different library. So if you want to have deeper conversations about NgRx, do make sure to join them. There's great community help as well. Thank you for having me today. I was very excited to present for the first meetup in the Angular Belgrade. Really big honor. Yeah, thank you, Marco, for inviting me. So I'd like to get some Q&A as well. So if you have time, type the question and we'll get to the question.
Yeah, here we have 3 questions. First is there any tutorial or guide for using Angular Fire with Component Store?
Yeah, so from what I hear, some experts in Angular Discord, this is pretty good stuff for Firebase. It could be. So Firebase is itself a reactive thing, right? But you do want to share some of the Firebase data sometimes. And again, this mix of NgRx and Firebase was always interesting because they kind of do some things commonly, right? They have this reactive state. It's just you have to be aware which state of it goes over the wire to the Firebase in general, and which states you can still reuse within your application. So again, remember that persistent state, like not all the state goes to the backends, right? Like which tabs open and all that. But then the persistent state could still be reactively populating your state containers. It could be working with a global store if your data is global and shared. It could be working with your component store as well. So it could be both. Yeah. Hopefully that answers the question. Let me know if it doesn't. If there any tutorial and guide for using the Fire Angular, and I don't have it probably yet. I'll be curious if somebody creates it, please point at me. It'll be exciting to look at it as well. Thank you.
Second question is, how can Component Store be used together with NgRx Global Store?
Yes. So thank you for this question, Igor, and Manuel, by the way, for the previous one. Yeah, so they can be used. How can they be used? Global Store could still have some of your global data. For example, in Firebase, one of the most global data is like, for example, the project that you're on, right? So they'll have like a project ID, right? That the user, and then it has so many other functionalities inside, but it's almost used for every single request that we send for the backend, like for which product specifically you do. So somewhere deeper, we'll have a component stores that inject a global store, right? And then select the product ID. So we'll have a selector for it. And remember how so again, one of the things, don't resave it in your component store, but you can use it, for example, in the effect. You do the request, you'll also use the data like with latest from component from global store, right? So you'll select that, for example, global piece of state that you need for the requests, and you make those requests and you save them in your component store. So they could be used pretty much well. Usually it's not pushing anything, not dispatching anything to the global store, but using some of the information from the global store. This is probably the most frequent interaction between those two. But again, they could be used by itself. They could be used together. They're completely separate and standalone. Thank you for a question.
Yeah, and the last is, where's the best place to put the synchronization logic when you need to use multiple component store in one component? So
yes,
in another service or facade, yes, or in components itself.
Oh, I see somebody who was already playing around with the component stores. Great, I love this question. Like all questions are great. Edis, this is a very nice question as well. So the way we approach this, and actually had one of the slides there I just skipped. So you could, my ideal case is you still inject a single component store into the component, but that component store can inject higher level component stores into it. Remember that use case B where it was a local one? So it's fine to create a component store that's just local. Moreover, sometimes it doesn't even have the state. Typically it would, but it doesn't necessarily could have a state, but it still could be used as reactive facade almost, getting data from different other component store, combining it together in selectors, because again, they're super high performant, right? And again, they would be only living for the life cycle of that particular component, right? So you could do that. I won't recommend injecting multiple component stores into the component. I would create a component store that basically is one-to-one to this component, right? And in there, you'll aggregate the data and do all the fun things. Should you even call upstream to do something, I would alias those things, alias those effects. I won't recreate specific effects for the upstream components, but I will alias the effects and have it all that way. Hopefully that was somewhat clear. If it's not clear enough, do find me on the Discord, one or the other. You can tag me to the question there as well. I'll try to get to it once I can get to it. But yeah, thank you for the question.
Yeah, thank you. And thank you very much, Alex, for a great presentation. We really enjoyed. Thanks
for having me. Thanks for good questions. Love it. Wish a lot of success to the Angular Belgrade, and thanks a lot, Marco, for starting it. And one more time, I'd like to call out Marco because he's been doing some fantastic contributions to the NgRx monorepo lately. I was super excited and happy to see them. Thank you.
Thank you very much. And thanks everyone for coming. Next meetup will be in January. We will have 2 talks. First will be about Spartacus. Spartacus is e-commerce Angular library. And second talk will be about NX monorepo tool and micro frontends with Angular. So thank you very much and see you soon. Bye-bye.
Bye.